Now, there's another type of variation which is called combined variation. And combined variation, as its name implies, it combines both the direct and inverse variation. The combined one combines both the direct one and an inverse variation. Okay, so Gauss' law is a perfect example where direct variation is applied and also an inverse variation is applied at the same time. Okay, so now let's write it. I'm going to write this one. So the subtopic is combined variation. Combined variation. All right. So now look at how it reads. A Gauss law states that the volume of an enclosed gas varies inversely as the pressure and directly as the temperature. The volume, let's write it. The volume varies inversely as the pressure, 1 over P. And the volume also varies directly as the temperature. Volume varies directly as the temperature. You see the first volume of an enclosed gas. Once you have a gas, let's pick examples of things that contains gas. Let me give you, can you all see this? Things like aerosol. Yes. This is an enclosed gas right here. There's a gas here enclosed. There's also gas in the gas tank that is used for cooking. There is a gas tank used in aerosol shelter. Let me give you one more example where you have gas. Look at this. So there's gas right here. So when you spray it, it will pull out something. There's also gas. There's also gas here. So now it says that gas varies inversely as the pressure, and gas also varies as the temperature. So now this is combined variation. So what you do would be, you can say that V, when you combine these two, V will vary directly as temperature over pressure. And it follows that V is equal to KT over P. So that's Gauss law right there. You can verify this with your biochemical instructor, or you just Google it. You can Google Gauss law and see what it gives you. Okay. So now let's try to solve a problem regarding this type of situation. So here's a problem. So write an equation relating pressure, temperature, and volume. We just did. Find the pressure when the temperature is 300 Kelvin and the volume is 700 cubic centimeters. Before we do that, let's try to determine K in a particular situation. So you can say the pressure of a gas is 0.75 kilogram. The pressure of a gas, this is an example I'm now giving. The pressure of a gas, is 0.75 kilogram per square meter. kg, this unit doesn't really matter, so let's forget about the unit for now. And the temperature is 294 K. Temperature is 294, and the cubic volume is 800 cubic centimeters, and V is 800 cubic centimeters, cm cube. So now let's determine K, given all these numbers. So So you will see that V, just plug in the number back to the equation. So you are going to have 800 is equal to the K we don't know, multiplied by temperature is 294, divided by pressure is 0.75. Okay, so we want to find out K. Somebody, we need help. How do we get K? How do we solve for K in this type of equation?
You'll start by multiplying both sides by 0.75.
Thank you. So basically you are cross multiplying. That's just you are just cross multiplying. So you are having 800 multiplied by 0.75 is equal to 1 times the other side will give you the same number. K equal to, no, K multiplied by 294. What's next, please? We're looking for K. What's the next step?
You would divide
Both sides by
294.
Exactly. So now you divide. Thank you. 294. Divide 294. And this crosses out. So you're left with K on the right side. So now punch in the number to get the value of K.
2.04.
Okay. So somebody said it is 0.04 is equal.
I said 2.04.
Sorry?
2.04.
I'm sorry. I didn't hear that correctly. Let me punch it myself. I didn't hear you correctly. So let me punch it myself. I'm not saying you are wrong, but I didn't hear you correctly. Just give me 1 second. I'll just say 800, 800 multiplied by 0.75 and then divide by 294. Okay, 2 points. Okay, you said 2 points. Okay, I didn't hear that correctly. Maybe the speaker or something. Okay, 2.04 is the K. Okay, now here's the problem. They want us to find the pressure when the temperature is 300 K and the volume is 700. So the question is find what? Pressure, find P when T is 300 K and volume is 7,000 cubic centimeters and volume is 7,000 cubic centimeters. You see, that's what they want. And that takes us back to our formula. The formula is V equal to KT over P. And they want us to find P. Okay, so now let's just plug in back the number. We're plugging back V, 700. We have 7,000 actually, equal to K is 2.04. 2.04 multiplied by temperature, which is 300. And then divide by.
Where did you get the 7,000 from?
Yeah, 7,000 is given to us.
It was in the problem.
7,000 is given to us. So the problem says find the pressure when the temperature is 300 K and the volume is 7,000 cubic meters. So that's a given value. Okay. So we basically know the we found the K, right? And then they gave us temperature 300 Kelvin. And then they gave us what again they gave us? They gave us the volume 7,000. And then they want us to find P. Okay, so how do we do that mathematically? Explain to me the steps we need to take from this point.
You can cross multiply.
Thank you. So we still do the cross multiply. You see, that's a very important concept in math. So we just say 7,000 multiplied by P equal to 1. 1 times anything is the same number. It would be 2.04 multiplied by 300 multiplied by 1. What's the next step? To find P. To find P, what do we do?
Wouldn't you just divide 7,000 on each side?
Yes, divide both sides by 7,000. Okay, so she said 700 times P over 7000 is equal to 2.04 times 300 divided by 7,000. So that crosses this out. And then we just use our calculator to punch in the number. So 2.05 times, that should be 600 and something. So use the calculator and let's get the value. Pressure will be, so we have 2.04 multiplied by 300, then divide by 7,000. So that's pressure will be 0.087. That's the pressure. That's the pressure. This is real scientific. What we just did right now is real scientific computation. It's real scientific computation. Without this, what we did now, without what we did, they cannot tell you the volume of gas in a container like this. If you look at a containers like this, somewhere you will see where they say the volume, the content of this gas. And when you press it one time, the quantity of gas that is going to pump out. So this has real life application every single day. All right. So time now is almost 9:30, and we still have a lot of time. We still have about 25 minutes. Question.
It's okay, but why did you wait to the end to multiply the two terms?
Well, I don't have to wait till the end. You can just, once you get the number, you can just multiply it out immediately. You don't have to wait.
Okay, thank you.
Yes. You don't have to wait. So once you get 2.04 times 300, you can just multiply it out and then write down the number. If we did that, we are going to get the same result. So if we did that, it would have been 7,000 equal to, let's just do that. 2.04 multiplied by
612.
what?
612.
Okay, 612. And that's over P. And you will still have to do the cross multiplication. And once you do that, you're going to have 7,000 P is equal to 612. So P will be 612 over 7,000. So you have 612 divided by 7,000. The same number. You're going to get the same number.